Okay, let's do what we gotta do. We'll play one short game, and we're gonna go to lunch early. Okay, today we are computing centroids. So the formulas are on the worksheet for 2 and 3 dimensions. Now let me kind of explain how these formulas come about. This is physics. Do you guys do like center of gravity?
Yeah.
Yeah.
Center of mass?
Yeah.
And then centroid?
Yeah.
I said yeah already.
Sian is not in physics.
Okay. Let's look at a 2-dimensional thing then. What if you have a 2-dimensional figure? Something like this. Okay? Okay, here's the region. Okay, let's look at center of gravity. So where would the center of gravity be? So like when gravity is a force, yeah? So when a force acts on this, didn't you guys learn that it's the same as the force acting on the center of gravity?
Yes.
Okay, so let's say this is the center of gravity. Then, so do you guys know the word moment then, right? Moment of gravity, moment of force. It's like the tendency to rotate something. So if you apply a force here, doesn't it attempt to rotate it around the y-axis?
Yes.
Okay, I'm trying to use my limited physics knowledge here. Okay, so the moment about the y-axis is the force that's applied here multiplied by the distance from the y-axis. Yeah? And then the moment about the x-axis would be the force acting on this point multiplied by the distance from the x-axis. Didn't you guys you learn about moments of inertia and things like that?
Yeah.
Explain that to me. Isn't that like attempting to rotate it about something? Wait, everybody here took physics and you guys got 5s on the AP exam. I had a D in physics and I can remember something like this. Okay, so we can apply the same thing to like center of mass. If this is the center of mass, that's like, mass is not a force, but what is mass? It's a scalar. That's like, you can think, okay, so the mass of this region, you can think of it as just all the entire mass at the center of mass, right? And again, this is the moment about the y-axis, and that's the moment about the x-axis. And then you can think of the same thing for like a centroid. The entire area is just located right there. And again, the moment of area would be the area multiplied by the distance from the y-axis and the distance of the x-axis. So if you look at the formula there, so in 2 dimensions, the x-coordinate of the centroid would be, what is this? No, sorry. Divided by this, over omega dx dy. This is how you compute the x-coordinate of the centroid. So what is this then? That's the area of the region. And then if you multiply it to this side of the equation, then you're going to multiply it by the x-coordinate of the centroid, which is that distance there, right? So that's how you compute the moment. And then, see, this is the moment about the x-axis, right? Because x is this distance there, right? Multiplied by that, if you think of that as an infinitely small square, and then you add up all of these squares in this region, you get the total moment. You guys talk about that in physics, the total moment? So the total moment of all the points here should be the same as the moment at the center of mass, right? And that's what this formula is. I mean, but ultimately, you're just going to memorize it anyway, right? So the y coordinate of the centroid would be the whole integral over omega y dx dy all over basically the area, yeah? And then we can extend it to 3 dimensions. I'm not gonna write the formulas, you see it over there. So we're just gonna go through one example and we're done. But let's do a 3-dimensional example, because that's the kind you're gonna get on the test, which is next week already, right?
Wait,
Yeah.
that was 24.
Hmm?
Isn't it next Tuesday?
Oh, that's because I postponed it to the next, extended, right? Because you want a long time on this test. No, I'm serious, you're gonna have crazy integrals you gotta do, maybe even z substitution.
No, do we get notes?
Please,
I wasn't planning.
please.
Can we do a group test?
Yeah, the entire 8 other people collaborate and just us 5.
Yeah, that's pretty
No,
cool.
okay, then I'm not gonna curve anything then, at the end.
Be quiet, guys.
Wait, that might be.
No, at the end. Okay, if you want to get this test.
Okay, then we're just going 89.5 is the A then,
Sorry,
No.
nothing lower.
sorry.
You know, like how, what was the cutoff in the first quarter, 83? We'll raise that to 89.5 then if you guys wanna have a group test.
Who's that?
And you only, also only group test for this test, now the last test is,
Is that harder?
might be. Come on, it's just integrals, you guys should be experts at integrals by now.
I think silver. Isn't there a test that improves too?
Oh yeah, we'll have a test on proofs too.
It's 4 tests.
But that's easy. Okay, let's do a cone. Okay, if you have a cone, like a right circular cone, where would the centroid be? Exactly where, like, if this is the radius and this is the height,
Oh, 1/3.
1/3, are you sure? Why would you say 1/3?
That's a triangle.
1.
Wait.
But it's not a triangle, it's a 3-dimensional
Oh.
thing.
wait a minute.
So here, what if we put, the x-axis here, the y-axis there, and here is the z-axis. Okay, what would be the coordinates of the centroid? Well, obviously by symmetry, it would be what? What would the x-coordinate be? 0. Y-coordinate would be 0. It's just the z-coordinate. Where would that be? So you guys are predicting, well, if we call this h, you guys are predicting h over 3.
1/5. That's my fifth.
Well, it would be, it would be h over 2, but there's way more volume down here, so it's gotta be somewhere here, right? So you said h over 5? No, this is just a guess. Come on, we just wanna see how good. Okay, everybody's gonna have a guess, so. H over 3.
What does that even mean?
Huh?
Not like the central.
The centroid.
Like center of mass.
Like if you have a uniform gravity field,
No, but why does it have to be 0, 0?
because of the symmetry of the
Oh.
cone, right?
Oh.
Right? Gotta be 0, 0, right? So that, you don't have to compute that. Okay, so that's Song's guess. Part,
H over 3 root 3.
Learner,
H over 6.
ooh, that's interesting. Kanashiro,
H over 5.
Hong,
Can it be like 2h over 7?
yeah?
Whoa. Let's go.
Okay, I don't know what it is, okay, so this is the first time I'm doing it. Okay, so let's figure it out. So to compute the z-coordinate of the centroid, what does it say to do? We gotta do a triple integral over the volume thingy. I guess we're gonna go dz, dx, dy, I'm guessing. No, dy, dx. Ah, you dummy. dy, dx, divided by the triple integral of dx, dy, dz, which of course is the volume. But we already know what the volume is, right? We're not gonna do 2 integrals when we don't have to, right? What's the volume of a right circular cone? 1/3 pi r squared h. So that means we just have to compute the numerator over here. How do we do that? We need to write the equation of that thing. We need to write the equation of the surface. When you smash it down onto the xy plane, that's easy, right? It's just gonna be the circle of radius r, right? So, to me, this is the hardest part of the problem. How do you write the equation of this quadrant cone? That was a big hint right there.
Z squared equals H.
Okay, well, isn't this the equation of the quadrant cone? But then you got both of them, you got the one going up and the one going down, right? We only want the one going down, and then we're gonna shift it up h then, yeah?
H minus X squared on top.
So what?
H minus root x.
So right here?
H minus root square root of x squared plus y squared. Z equals.
Okay, say that again? H?
Only z, not z squared, equals h minus square root of x squared plus y.
Does that work?
Yeah.
Well, we need, what about this r? Shouldn't there be an r in the equation? Because we need that to be r.
Isn't.
So is the, okay, let me ask you this, is the x and the y-intercept r? How do you find the x-intercept? If I said z and y equal to 0, then you're gonna get r for the x-intercept. Well, I don't think so, because there's no r even in the equation. There has to be an r in the equation. And then, of course, the xy trace should be the circle x squared plus y squared equal r squared, right? How do you get the xy trace?
Z equals.
You substitute 0 for z. If I substitute 0 for z, do I get x squared plus y squared equal r squared? No. And then what about the xz trace? Look, that's a line right there, right? Oh no, sorry, that's the yz trace. In the yz plane, what is the trace? Isn't it the line, this line right here? What is the, okay, what's the equation of this line? Z equals
H
h
minus
minus
square root of y.
h over ry. Because y's over run, right?
Can't you just put in h over r in front of the square root?
I don't know, does that work? See, this is the hardest part, you gotta write the equation of the cone.
Yeah, that should work.
Okay, let's test it. Is the x and y intercept r? How do you find x-intercept? You substitute 0 for z and y. What happens when you get that? 0 equals h minus h over r x. So you get, yeah, x equal r. Okay, that works. What about the yz trace? If I plug in 0 for x, what happens when you plug in 0 for x? You get z equals h minus h over ry. Is that what that is? Good. This works. You're going to be able to do this on your own on the test. That's why we're going to have a group test, Mr. Parker. Okay, everybody agree? Does that cover everything? What about the xy trace? If I plug in 0 for z, if I plug in 0 for z here, do you get the circle x squared plus y squared equal r squared? Well, let's try. You would get h equals h over r root x squared plus y squared. H's cancel out. Yeah, oh, what?
X squared plus 4.
Oh, this is 1, that's why. Yep, you do. So that looks good. Do you see how we came up with that, though? Well, how Park came up with it? Okay, so let's write the integral. How do I compute this one in? So triple integral of z dz dy dx. Okay, so when I integrate with respect to z, you're gonna go from the bottom to the top. What's the thing on the bottom? Which is the xy plane. Z equals 0 to this thing here. Okay, and then when you smash it down onto the XY plane, you're gonna see this. R. So, what would it be? Come on, the equation is x squared plus y squared equal r squared. So the upper semicircle would be y equal square root of r squared minus x squared, right? And the bottom would be y equal negative square root of r squared minus x squared. Okay, so you want to do that, or you want to just go 0 to that and times it by 2, because we do have symmetry here, right? Okay, so 0 to square root of r squared minus x squared times 2. And then x is going to go from negative r to r, or we want to go 0 to r times it by 2. Yeah, I think so. So 0 to r times by 2. Okay, so now we just have to compute this integral. We need to erase it because we need some room here. Can I erase all this? Okay, everybody remember your guesses?
Bottom's the closest.
How do you know? Oh, you looked it up already. You're not supposed to look it up, gotta do it. Don't give it away. Okay, now you gotta decide. Should I compute this using rectangular coordinates? Might get kind of messy. Or should I change it to like polar?
Polar.
Or which is cylindrical basically, yeah? You know what? Anytime you see an x squared plus y squared in there, you probably want to do polar. Okay, so if we do polar, how is this going to change? The integral, let's do it over here. It's going to be 4 triple integral. So the first one is going to be 0 to h minus h over r. Isn't that just r?
It's just 0.
Wait,
So there's no.
wait, how is that even possible?
What, X and Y change?
What?
X and Y change.
Oh, because root.
What do you mean x and y change?
Root x squared plus y squared changes. Otherwise.
Yeah, to r, but then the r will cancel the r.
So this is.
Like this, it's going like this. How are you going to get h minus h to 0 to 0?
No, isn't it not like,
Because it's going to be z, and then it's going to be r dz dr d theta, right? When you change to polar. dx dy is the same thing as r dr d theta, right?
yeah. Or, but like the R is like a different value, like it's like a set value, not,
Oh, r is a constant.
yeah.
Oh, okay, see. Yeah, let's use big R then for R. Oh! Good thing somebody said something. So this is capital R. This is capital R. This is capital R. Okay, now that makes sense. H minus H over R. Okay, and then what is R gonna go to? Okay, because remember your omega region is like this, right? So R will go from 0 to R, and theta, you gotta go all the way around, so 0 to 2 pi then, right? So we gotta compute this integral. Woo! Okay, first step, integrate with respect to z. What is the integral of this with respect to z? 1/2 r z squared, is that correct? From 0 to h minus hr over r. Factor out the constant. So 1/2 r h minus hr over r squared minus 0. Now we got to integrate this with respect to r from 0 to r. Okay, do I need to multiply out, or can we just do the antiderivative? Can, right?
Yes.
Without doing a u substitution. Oh, no, because we got this r.
Yeah.
Oh, we got to multiply out. Darn it.
Wait,
What? If we didn't have that r, then we could do it. But Cannot do U substitution either, right? Okay, what do I get? Whose turn is it? Palm, multiply it all up. Square this and then times it by R.
RH squared minus 2R squared H squared over R plus H squared R squared over R squared and give us.
Didn't the two cancel out?
No, the half is out.
I put the half out here.
Um,
So is she correct?
yeah.
Before we move on, we gotta make sure this is correct.
R cube. Oh, I-
Where's our cube?
The last.
R cube. Is that what you said, huh?
Oh, yeah. Didn't see that.
Sorry.
Okay, next step, find the antiderivative. Song.
R squared H squared over
Wait, what? Okay.
Big R
two
plus
R
small.
cubed H squared over two R.
Say that again?
H squared over two R. No, I'm stupid, 3R.
Plus
H squared R to the fourth over 4R squared.
Oh, that's nice.
All right. Plug in the top thingy. Okay, I think I can do that. I think R squared H squared over 2 minus 2 R cubed H squared over 3R plus H squared R to the 4th over 4R squared minus 0. Does that simplify to something good? Yeah, it does, yeah. So,
Oh.
I can't do this in my head. I'm gonna have to write it out. 2R squared H squared over 3. Tell me if I'm doing it right.
Yeah.
H squared R squared over 4.
You can combine the first and last.
You can mind all that.
Yeah, you can combine all of them, right? Did I do that right? So least common denominator, can we do this in our head? 12. 6 minus
One,
8
12.
plus 3. What did I just say? 6 minus 8.
Plus three.
It's 1
That's just 1 then.
Yeah.
So it's just 1/2
1
R squared H squared over 2?
24.
24.
1/24. Is that right?
Yep.
Okay, now we gotta integrate with respect to theta from 0 to 2 pi, and don't forget the 4 in the front. Yeah, we just throw that in later. So when you do this, since there's no theta here, it's just multiplying by 2 pi then, right?
Yeah.
Right, so we got R squared H squared over 24 times 2 pi times that 4 there. So if we simplify that, this doesn't even sound right. No, it is right. So wait, 6 goes into this 4 times, 3 times. So we got 1/3 pi,
Hey, that's up somewhere.
what?
That's not that right.
That's like.
No. But now we gotta divide that by the volume, right?
Yeah, but even if you.
So 1/3 pi
Oh, that's.
R squared H. So we get,
It's at the top.
It's on the top. It's on the top.
what?
It's at the
What? What do you mean it's on the top?
Eight is
It's
the top.
the top.
What?
If our answer is 8,
No, it's not, that's not the answer. We did something wrong. Okay, did anybody see anything?
Maybe we double
answer should be 3. No, it should be a 4.
H over 4.
Yeah.
Who guessed that? Nobody. Nobody guessed it. It's H over 4.
Yeah, I guess H over 5.
Huh.
Wouldn't you get that? Maybe we did like twice the height on accident. Or that's dumb.
Okay, go back to the original problem. Is our original integral okay? H minus HR over R times R. Again, that looks right, doesn't it?
Or the last one, why is it 0 to 2 pi when we times it by 4? Or theta?
Oh, yeah, you're right.
Oh, that's where that over 4 comes from.
Wait, how come over here?
No, because we changed it to,
Oh, that's because of the symmetry.
yeah.
So the force shouldn't be here at all,
Yeah. So then
because we
that's-
changed it to polar.
Yeah.
Oh, so we got the right answer
Yeah.
then. So not supposed to have this 4. So then what should it be? That should be 12 then, yeah?
Yeah.
So
So
that's the
one-
top then, yeah?
Yeah.
So 12. So now we get H over 4.
Yeah.
Yeah.
Oh.
Woo! See what happens?
See you.
See what happens when you change it? You gotta, yeah, so. Maybe we shouldn't do the symmetry thing. Yeah, and then just after you write the integral, then you decide. Anyway, that's kind of an unexpected result. 1/4 the way down. I mean, 1/4 the way up. I guess that kind of makes sense though. Now, since we did this, because I think this was a test question last year, I gotta change it now. So you would have had 0 on this problem. See, look how much work you have to do just for one problem. Did like 10 of these.
10?
Yeah.
How does that do that?
Huh?
How do you do like y(x) to like r?
Because in polar coordinates, isn't r squared equal to x squared plus y squared? Yeah, that's the substitution. So you can, yeah.
No, like,
Well, just for this one,
yeah.
just for this one.
They changed
Because
it.
we changed it to polar, so the omega region here, since the radius of the circle is r, the r goes from 0 to r, right? And then you gotta go all the way around to 0 to 2 pi.
No. Like, does dy dx like equal to, is that like?
So
almost
this-
equal to r?
Yeah, this is the same thing as r dr d theta, right?
That doesn't change. It's like a
No,
different-
it changes. Right, that we already had the homework on that already, yeah. Oh, that was kind of exhilarating.
That's cool.
Okay, now I gotta figure out what I'm gonna give you since we did it in class. Or maybe I should just give it to you again, because remember the last problem on the last test?
Oh, yeah.
How many people got a squared? Well, some people wrote down a squared plus b squared plus c squared, but I don't know how they got it.
What was the other two?
I thought it was some similar.
Okay, we'll play one game and then we'll go to